Determine the melting efficiency in the case of arc welding of steel with a potential of 22 volts and current of 230 amperes. The cross-sectional area of the joint is 22 mm square and the travel speed is 5 mm per second. Heat required to melt the steel is 12 joule per millimeter cube and heat transfer efficiency as 85%. In this question, we need to find melting efficiency, eta m. So we need melting efficiency, and the given data is given voltage, so potential difference V is equals to 22 volts, and also given current I is equals to 230 amperes, and cross-sectional area of the joint is given. So cross-sectional area, so area of the joint A is equals to 22 mm square, and travel speed V is equals to 5 mm per second. Okay, still given heat transfer efficiency. So heat transfer efficiency is denoted by eta ht, suffix ht, is equals to 85%. 85% means we can write it as 0.85, in decimals 0.85. So we need melting efficiency. What is the formula for melting efficiency? Okay, so melting efficiency is equals to, formula is Hm by Hi. So what is Hm? Hm means heat required for melting the joint. Heat required for melting weld joint divided by Hi, heat input or heat supplied. Okay, now so eta m is equal to heat required for melting weld joint is already given. So heat required for melting steel is equals to 12 joule per mm cube. Okay, it's already given. So here only unknown is Hi. We need to find Hi. So heat input. So 12 by Hi. So what is the formula for Hi? How do we get Hi? Hi is equals to heat input is equals to voltage into current by area of weld into travel speed into heat transfer efficiency. So this is the formula for finding heat input or heat supplied. Let us substitute all values in this formula, then we will get Hi. Now Hi is equals to voltage how much given? 22 into current 230 amperes divided by area of weld 22 mm square into next given travel speed 5 mm per second into heat transfer efficiency 0.85. So 22 get cancelled, 5 ones are and 5 fours are 20. Okay, so 5 fours are 20 and still we have 30. So 5 6 are 30, so 46. So Hi is equals to 46 into 0.85. Okay, if you simplify you will get 39.1 joule per mm cube. Okay, so input how much? Heat input 39.1 joule per mm cube. Heat input or heat supply. Now let us find melting efficiency now. Now melting efficiency eta m is equal to heat required for melting 12 joule per mm cube. Now heat input 39.1 joule per mm cube. So joule per mm cube get cancelled. So therefore melting efficiency is equal to 12 by 39.1. You will get 0. Approximately 307. So in percentage, just multiply by 100. You will get 30.7%. Therefore, melting efficiency is equal to 0.307 or 30.7%. This is our final answer.